Simulators. When I design a circuit, I may come across many difficulties and adventures. It might be easier to build simple electronic circuits physically, but once I start to build complex circuits, it will be difficult to predict the output of the circuit. That's where simulators comes in. Before building a circuit physically, we first design it in a simulator, in which we can give inputs and know the outputs. The simulator which we are going to use is LTSpice. Using LTSpice, we can place various components. We can wire the circuit. We can give an input and get an output. And there are various possible simulations. And I will show you DC simulation. These are some important shortcuts which I can use in LTSpice. I open LTSpice. So first we need to open a new schematic. This is a new schematic. Let's build a simple circuit with LEDs. This is a simple circuit which I have a source of 9-volt battery, and I connected it across a resistance which is 470 ohms, and I connect 3 LEDs in series. This denotes the ground, without which we cannot measure inputs or outputs, which is called as reference. So the first thing I need is the voltage. For that I need a voltage source. I press F2, which gives me a pop-up, and I have all the components. I type in voltage and then I get voltage source. I give OK and just place it here. If you need to zoom in or zoom out, you can use these two icons here. So I want to zoom out. Then you need to specify how much voltage you are giving in. So you right click on the component, then you give a voltage of 9. Then I get a resistor from the components. Then I need 3 LEDs. So I go inside and type in LED, give OK. So I place it here. So before choosing an LED, we should specify the model number. For that I need to click on this. I just right click and I pick a new diode. Here when I'm choosing an LED, I choose the most commonly used one, which is this one, Initia. So actually if you select this, and if you see that the average forward current it uses is actually 30 milliamps and the breakdown voltage is 5. I need 3 LEDs, so I can just copy this LED and just place it. For that I can press F6 and this icon shows that I can copy any component. So I click on this and I copy. I need one more, so I again click and copy. Then I need to wire the circuit. I can use F3 to wire. So when I press F3, it wires, the wire comes up. Then I click on the square one, so it connects to the components. So this is how I connect. I wire the circuit. Then I need a ground reference. Then I press G and get a ground reference, and again connect this to here. So then I give a value for the resistance. I give 470 ohms. Before running the simulator, you can save the file. You can use this run button to run the file. Then this window pops up. So what I am going to do now is I am going to do a DC sweep where I can give a starting voltage and a stop voltage. I do a DC sweep because the battery which we are using in practical applications can decay very fast. So it asks for name of first source to sweep, which I give V1. Then the starting voltage I give it as 0. So the stop voltage I give let's say 12 volt. Then the increment, which is the slope, I want to increment the slope by 0.1. So when I give the values, the simulator runs, and if you want a vertical window, you can also choose. If you want to see the input and output, you go near where you can find this red color pen like structure, then you click, and here I gave a sweep of 0 volt to 12 volt, which is shown here. Then after the resistor, the voltage is shown, and you can see the curve actually starts to bend here. So actually this indicates that after 7 volt the input voltage changes. I want to see the voltage across D1, so I click here, and I want to see the voltage across D2. You could actually see that the voltage across each diode keeps on decreasing. To be more clear, I click on this, so it shows me 2 lines. I can drag this here. Let's say I give an input of 8 volt. So at across diode D2 the voltage will be 2.5 volt. Across diode D1 we could find it in a similar way. So across, when I give an input of 8 volt, then the voltage across D1 would be 5.13. The voltage after the resistance will be 7.7 volt. If you want to see the current, you could actually click on the components, and this arrow mark, which is in red color, it shows the direction of the current. So if I want to see the current here in D1, then I click on it, then I could actually see that after 7 volt or maybe a little after 6 volt my LED starts to glow. That's where the current passes through the LED. So when I increase the voltage and the current increases, you'd actually see that the current in each diode is the same. This shows that the voltage changes but current remains the same.